This is Unit 4, Lesson 1, Part 2, Factoring Any Trinomial. And we learned in the last section how to do trinomials like this. We're going to extend that a little bit further in this part of the section. First of all, let's review. If we look at this, in order to factor that trinomial, the first thing we're going to do is take out anything that they have in common. So we're going to look at the whole thing and see if there are any factors in common. Well, it looks like they all have a 3 that can come out, and it looks like they all have an m that can come out. So I'm going to bring out a 3m first. That leaves me with n squared minus 10n plus 9. And then to factor that trinomial, my coefficient is 1 here, so that makes it pretty easy. We're looking for factors of 9 that add to give us 10. So the 3m comes down. I'm going to set up my 2 sets of parentheses for my binomials, and then the n squared, we're going to have an n and an n. Square root of n squared is n, so that goes in both of those. And then factors of 9 that add to give you 10 would be 9 and 1. This plus tells me these signs are the same as this sign, so they're both minuses. And that would be the answer to that one. For the next one, let's pause the video and see if you can get that one on your own, and then we'll come back and check it. Well, if you look at this one, first of all, I brought out a 2y. Then I have x squared minus 4x plus 24 left. And then we're looking for factors of 24 that add to give you 4. Well, here are the factors of 24 listed. None of those numbers will add to give you 4. So we can't go any further. This would be our answer. And remember, that's not prime. We did have something that came out, so we factored something out. So we're not going to say that that one's prime. We just can't go any further than that right there. In the next one, this is a little bit different. Hopefully you notice we've got an a squared here and we've got a b squared here. Now, the way we factor this is not any different than those simple trinomials that we did where we have a coefficient of 1 here, but it looks a little bit different because of that b squared. If you notice, the middle term here is ab. So when I factor this, well, the square root of a squared is a. So just like before, we're going to have an a and an a in those 2 sets of parentheses. We're still looking for factors of 4 that add to give you 5, which would be 4 and 1. So I need a 4 and a 1. But now we also need the square root of b squared to be in each of these. So we need a b here and a b here. So we would have a 4b and a 1b. Now understand, 1b is just b, so we could just put b instead of the 1. The plus sign tells me these have the same sign, and the sign is a plus, the same as the middle sign. So these are both pluses. Then if you FOIL, look at what you end up with. A times a is a squared. 4b times b is 4b squared. For our middle term, a times b is ab. 4b times a is 4ab. So ab plus 4ab is 5ab. So it does work out. So when we have 2 variables in the middle term like that, what that means is we're going to have 2 squared terms on the outside. So you're not doing, the method is not any different. You're just going to tag that extra variable on the right-hand side of each binomial. So let's do another one. In this one, I know it's a trinomial. Doesn't look like anything comes out of the whole thing. The square root of x squared is x, so I have an x and an x. Here we have a y squared, so I know I'm going to need a y and a y. And then I could do my numbers. Factors of 32 that add to give you 12. Well, if you think about factors of 32, we've got 1 and 32, 2 and 16, 4 and 8. Looks like 4 and 8 will add to give you 12. So if I put 4 and 8 here, and remember, it doesn't matter which one gets the 4 and which one gets the 8. You could do it backwards for me, doesn't matter a bit. The signs are what's going to make the difference here. The plus tells me these have the same sign, and they're both minus because that's what the middle sign is. So we've factored it. Again, you could always multiply them together to check to make sure you got that correct. All right, so look at these examples. What do you notice is different about these examples here? hopefully you're saying they have a number other than 1 in the front, okay? That's going to change things significantly for us. And we really need to pay attention when that happens to the numbers that we're putting inside our binomials. So this does complicate it a little bit, but if you know FOIL really well, this isn't too bad. All right, so what we're going to do is first, we still need to ask ourselves, is there anything that comes out of the whole thing? That's what we would want to do first. I don't see any factors that they have in common for this one, so there's nothing that comes out of the whole thing. Well, I'm going to put my 2 sets of parentheses there because I know I need a binomial here and a binomial here. And then what I need to do is I need to multiply 6 times 5. 6 times 5 is 30. Now remember, before we had mentioned really quickly that whatever is here, 1 times whatever was here, is the number we looked at. And we said before, like if there's a 1 here, we would have said, what factors of 5 subtract to give you 13? Okay? Well, now we're not doing that. We have to, when there is a coefficient other than 1 in the front of the x squared term, in order to be able to get the numbers that multiply together to give you the middle number, we have to multiply the first coefficient times the last term. So 6 times 5 is 30. We have to do that first. Once we get this number, that is the number we're going to find factors of. Okay, so here's what I'm going to do. I'm going to write that number here, and I'm going to say what factors of 30 subtract to give you 13. See that? What factors of 30 subtract to give you 13? Well, let's think about the number 30. We've got 1 and 30. We've got 2 and 15. We've got 3 and 10. We've got 5 and 6. Which of those numbers subtract to give you 13? Hopefully you're saying 2 and 15. Some of you might have said 3 and 10. Think about that. 3 and 10 add to give 13. I have a lot of students get that wrong just because they're adding instead of subtracting. So pay attention to the numbers here. Pay attention to the sign, the operation that you have to use. 15 minus 2 is 13. So those are the 2 numbers we want to use. Okay, now we have to determine what numbers go in here. Now this is still an x squared. We're still going to have an x and an x. But the difference here is now we're going to have coefficients in front of those x terms, because our outside and our inside terms have to multiply to give us 2 and 15. Okay? So let's think about this. Well, factors of 6. We have 1 and 6 and 2 and 3. Okay? So we could either use a 1 and a 6, or we could use a 2 and a 3. Now some teachers tell you to write both of them down and then try it both ways. Don't do that. That's too complicated. It just confuses things, I think. Look at what you need. You need a 2 and a 15. What factors of 6 would go into 2 and 15? 1 and 6 are not going to do it. 1 goes into both of those, but 6 doesn't go into either one. So 1 and 6 don't cut it. We got to throw that out. All right? What factors of 6 go into 2 and 15? Well, 2 and 3. 2 goes into 2, 3 goes into 15, right? 2 goes into 2, 3 goes into 15. So we need to use 2 and 3. Factors of 6 that will divide into those numbers we chose, 2 and 3. Okay? So we're going to use a 2 and a 3. All right, now, we need to make, with our outside and our inside term, we need to make a 2 and a 15. All right? 2 times what gives us 2? Well, 1. 3 times what gives us the other number, 15? Well, that's a 5. So we've got, our outside terms are 2 and 15. See that? Think about our signs. The minus tells me these are different signs. Okay? Well, if they're different signs, we know the big number gets the minus. All right, now think about the big number. We're talking about the big number here. Not necessarily here, but here. Which one of those is the big number? 15. Okay? So 15 needs the minus. Well, what makes 15? 5 and 3. So that needs the minus. The plus goes here. you could FOIL and see you're going to get that. Okay, let's do another one. Looking at this one. Nothing comes out of the whole thing. Got to check for that first. 3 times 25 is 75. We are looking for factors of 75 that subtract to give you 10. Factors of 75 that subtract to give you 10. Well, let's see. We've got 1 and 75. 2 doesn't go. We've got 3 and 25. 4 doesn't go. We've got 5 and 15. Oh, they subtract to give me 10. I'm going to stop right there. Okay? So I need to make a 5 and a 15. That's still x squared. I know each of these gets an x. Think about factors of 3. Well, the only factors of 3 are 3 and 1. So we need a 3 in front of one of them, a 1 in front of the other. I'm just going to leave it as an x. And then my outside and my inside term need to make 5 and 15. Well, let's think about that. 3 times what gives me 15? 3 times nothing gives me 5, right? We can't multiply to get 5. But we can multiply 3 by something to get 15. 5. So 3 times 5 is 15. 1 times what gives me 5? Well, that's 5. Now think about this. What's 5 times 5? Is it 25? Yep. Think about this. 1 times 5 is 5. Okay? My signs are different. If my signs are different, my big number, the 15, gets the plus. 3 times 5 is 15. That gets the plus. That one gets the minus. Moving on to the next one. Are there any factors that come out of the whole thing? I don't think there are. So 12, the first term times the last term. 12 times 5 is 60. So we're looking for factors of 60 that subtract to give you 28. Factors of 60 that subtract to give you 28. That would be 2 and 30. So we need factors that are 2 and 30. So I'm going to do my 2 sets of parentheses. I know that I need an x and an x. And then I need to look at factors of 12. Well, factors of 12 that will go into 2 and 30. Well, factors of 12 are 1 and 12, 2 and 6, 3 and 4. Well, which of those go into 2 and 30? That would be 2 and 6. So we need a 2 and a 6. So one of these will be a 2, one of them will be a 6. Then we need to do our outside and our inside terms. Well, think about this. 2 times what gives us 2 or 30? Well, we could do 2 times 15, but that's not going to be good for the 5 here. So we know it can't be 2 and 15. So it has to be 2 times 1 gives us 2. And then 6 times what gives us 30? Well, that has to be 5. So then you can double check, is 5 times 1 5? It is. So we know we've got what we need there. And then we know our signs. This is a minus, so these signs are going to be different. And the big number gets the minus sign. So the big number needs the minus. The big number here is 30. We need the 30 to be minus. So I'm going to put a minus right here because negative 5 times 6 is negative 30. And then this one would be our plus. For the next one, I'm going to look to see if anything comes out of the whole thing first. It looks like a 2x will come out. So if I do that, I have 6x squared minus 7x minus 3. Then I'm going to try to factor this trinomial. Well, when I do that, my 2x is going to come down. I'm going to do 2 sets of parentheses and factor this one just like I did up here. So 6 times 3 is 18. We're looking for factors of 18 that subtract to give you 7. See, once you take the 2x out, this trinomial is no longer there. That's not part of our problem anymore. Now we're factoring this trinomial. So don't get confused and think you need to do 12 times 6. You don't have to do that. You're going to factor the simplified trinomial. So factors of 18 that subtract to give you 7. That would be 9 and 2. So we need a 9 and a 2 with our outside and inside terms. I know I need an x and an x. Factors of 6 that will give us 9 and 2. Well, 2 would give us the 2. 3 would give us a 9. So we need a 3 and a 2. And then we have to do our outside and inside terms. 3 times what nothing gives us 2, right? 3 times nothing will give us 2, but 3 times what gives us 9? Well, that would be a 3. So 3 times 3 gives us the 9 we need. 2 times what gives us the other term we need, the 2? Well, 2 times 1 gives us 2. We know our signs are different because that's a minus, and the big number gets the minus, so the 9 gets the minus. Well, the 9 would be the negative 3 times 3 gives us the minus 9 that we need, and that would be your plus. Okay, so we factored trinomials that have a coefficient in front of the x squared term. Here are 4 more factoring trinomial problems. Go ahead and pause the video, try these on your own, and then we'll come back and check them in a few minutes. Okay, looking at these answers, I'm going to explain them real quickly. Nothing comes out of the first one, so I have to just factor it right off the bat. 14 times 1 is 14. Factors of 14 that add to give you 9 are 2 and 7. So I'm going to need a 2x and a 7x in the front of each binomial. Factors of 1 are just 1 and 1, so there's really nothing else I can do there. 2 goes into 2 and 7 goes into 7, so we know those are my factors. The plus sign tells me these have the same as this sign, so they're both minus. So there's the factoring of that one. For this one, they all have a 3t in common, so I brought the 3t out first, leaving me with r squared plus 2rs minus 48s squared. And this one is a little simpler because there's a 1 in front of the r squared term there. So we're looking for factors of 48 that subtract give me 2, which would be 6 and 8. So I put a 6 and 8 here. I needed an r in the front of each, and I also needed an s at the end of each binomial in order to have my middle term of the rs. So that was one of those with the 2 separate variables. For this one, nothing comes out of the whole thing. So I'm going to multiply 11 times 6 to get 66. I'm looking for factors of 66 that add to give you 35. And that would be 2 and 33, 2 times 33. And so I need factors of 11. Well, the only factors of 11 are 11 and 1. So I need an 11x and a 1x. And then I need to ask myself, 11 times what gives me 33? Well, that would be 3. And 1 times what gives me the 2? Well, that would be a 2. So 2 times 3 is 6, our last term. And the middle terms are 33 and 2. They do add to give me 35. For my signs, they're both the same because of that plus, and they're both pluses because that is a plus. For the next one, a 3 comes out of the whole thing. So I took out a 3, and then this is the trinomial that I need to factor. I do 3 times 45 is 135. So factors of 135 that add to give you 32, that ends up being 5 and 27. So I need a 5 and a 27 for my outside and inside terms. Factors of 3 are 3 and 1, so I've got a 3x and a 1x. And then 3 times what gives me the 27? Well, that would be 9. And 1 times what gives me 5? Well, that would be 5. 5 times 9 is the 45. The plus here tells me these are the same sign as that sign, so they're both minus. So hopefully you got those right. We'll do some practice on this, and we will use this extensively throughout this chapter.